Now, the way that we've just found the LCM for 6 and 8 by listing multiples is certainly a way that will always work, but it does have some drawbacks. It can be a pretty long and difficult process if we have numbers that are large, or if we have maybe 3 or 4 different numbers that we have to find the LCM for all of them. Plus, it's a way that does not work so well once we get into some trickier problems that involve a lot more variables. So we have a different way of working that at first it might seem like a little bit more work, but it is a way that is much more useful in the long run. So that's the way that I like to focus, and it's using prime factors. So we'll go back to this example of 6 and 8 because we know LCM of these two numbers is 24, but we'll look at a different process using the prime factors. The first thing I want to do is for each of these numbers, find prime factors, and I'll use a factor tree where I start with this number 6 and think about what two numbers multiplied together would equal 6. And when we're making these trees, we avoid using the number 1. So I wouldn't want to choose 1 times 6. I'll have to choose 2 times 3 instead. Now think about, can I do the same thing with the number 2? Can I say 2, I can get a 2 by doing this times that. And remember, we're not allowed to use 1 in the factor tree because 1 is not really a prime number. We have to stick to prime factors. So the 2, we can't break that up any further. We'll just put a circle around that and say that's a prime number. And 3 is also a prime number. And you might have some prior knowledge or just have good memory of this list of prime numbers, especially the smaller ones. But our thoughts are a prime number is something that the only way we can break it up into its factors would be using that number itself and 1. So 2, I can only do that by doing 1 times 2, so it's prime. 3, I can only break that down as 1 times 3, so that's prime. Okay, let's move over to this 8, and we'll do a factor tree. I'll come up with 2 times 4, and 2 is a prime. 4, we can break that down further and into 2 times 2, and those we've already decided are primes. So the prime factors of 6, 2, and 3. The prime factors of 8, 2, and 2, and 2. 3 2s. Now that we have the prime factors, we're going to build our LCM. Now this part right here might seem silly, but it's something that's helpful for me to remember what I need to do to find an LCM. Now first of all, the L helps me to remember that all the factors I see I'm going to have to use. I see some 2s, I see some 3s, they'll all have to be used. I know L all to stretch. And now, there's a catch because I don't want to just look at this and say, I see 4 2s, I want to use 4. That's really not how LCM works, and we don't usually want to think about finding totals. What I want to think about is where do I see the most? That's the CM. This is silly, I know, but it might be helpful, and that's the only reason I'm saying it. So we have to use all these different factors, but we only want to use them where we see the most, and I'll explain what I mean by that. First, think about using a 2. How many 2s do we need in the LCM? Well, we want to keep these two trees separate so we can see in this tree there's only 1 2. In this tree we have 3 2s. So think about in which tree do we see the most 2s? And I'd say it's over here on this side. It has 3 2s. That tells us that we need 3 2s in the LCM. And we'll go over a few examples to get these ideas working for you, but it's about in which tree do we see the most. That's how many factors we have to use in the LCM. Okay, now you're thinking we have to use them all, so we have to think about 3s. Where do we see the most 3s? In this tree we have 1 3. In this tree there are no 3s, so definitely over here is where we see the most, where we see 1 3, and that's how many we'll need in the LCM, 1 3. And there are no other prime factors. Don't look at that 4 because we're thinking prime factors only with this method, so I'm only interested in these numbers that are circled, like the dead ends of the tree. 2s we covered, 3 we covered, no other prime factors, so we finished building the LCM. The last thing we can choose to do is to multiply all these numbers together. 2 times 2, 4, 4 times that, 2, 8, and then 8 times 3, 24. Just giving us that answer that we expected to see, but we're seeing how we can get there in a different way using